Elimination. Alright, so we're going to write down what the elimination method is. Write that down on your paper, elimination method. I'm going to tell you what that method is. Can't even see. There we go. Alright, number 1. You're going to eliminate one variable. You can eliminate one variable by doing the following things. You can do it by either adding, subtracting, or multiplying. You can eliminate one variable by adding, subtracting, or multiplying. Number 2, you're going to solve for the other variable. Number 3, you're going to solve for the eliminated variable. And lastly, number 4, you're going to write it as an ordered pair. Four steps. Eliminate one variable by adding, subtracting, or multiplying. Solve for the other variable. Then solve for the one you eliminated, and then write it as an ordered pair. All right. Let's look at example 1. I'll leave the steps up there really quick so you can see. Alright, so I'm going to keep my steps next to me, and we're going to solve for example 1. I'm an input, so I shouldn't hear any voices. The directions will say solve by using elimination. Again, I'm an input, so I shouldn't hear anyone talking. Here's example A. I'll have 5x minus 6y equals negative 32. I'll also have 3x plus 6y equals 48. Please write those two down. Write them down. So step 1 tells me to eliminate one variable. Well, I'm going to look at this and I can see that I can already eliminate one variable because negative 6y plus 6y is 0. Okay, so go ahead and write next to it. Step number 1, eliminate one variable. So I'm going to eliminate right here. Negative 6y plus 6y is 0. And I'm going to do that by adding. So remember, in your steps, you can do elimination by adding, subtracting, or multiplying. If I add negative 6y plus 3x plus 6y equals 48, I'll eliminate that variable. So I'm doing it by adding. That's the method in which I did it. So what's 5x plus 3x? Oh, I know. That's 8x. What's 6y negative 6y plus a positive 6y? Oh, that's 0. And what's negative 32 plus 48? Oh, that's going to be 16. So now, 0's there. I'm left with 8x equals 16. Divide both sides by 8. And x equals 2. That's elimination. Eliminating one variable. Okay? So now, I did my first step. I eliminated one variable. Now, I solved for the other variable, which was here, step 2. I solved for x. I solved for the other variable. It's important that you write the steps right next to what we did, so you know where it is. I solved for the other variable. Now we need to do step number 3, which is to solve for the eliminated variable. So I'm going to pick an equation, plug x into it to solve for y. Okay? So I'm going to pick the second equation because I like that one. So I'm going to pick 3x plus 6y equals 48. That's the equation that I'm going to choose to plug x back into to find out what y is. So it's substitution, but you did it by elimination. You eliminated one variable first, then you substituted it. So I'm solving for x, or for y, excuse me. 3 times x, we found out was 2, plus 6y equals 48. Oh, 3 times 2 is 6, plus 6y equals 48. To get y all by itself, I'm going to subtract 6 from both sides. I don't know why people aren't writing with me. My 6's cancel. I'm left with 6y equals 42. To get y by itself, I'm going to divide both sides by 6. And y equals 7. So I just did step number 3. I solved for the eliminated variable. And lastly, step number 4 tells me to write it as an ordered pair. X is 2, y is 7. So on your paper, you should make sure that you have all the steps next to the work that we did. So the only difference between this and substitution is instead of taking finding one variable and then plugging into the other variable, you eliminate one, find the answer, and then plug it back in. So it's called elimination. Put your pencil up when you have that. Good. All right. Let's do example B. I have negative 2x plus 3y equals negative 9. And I also have x plus 3y equals 3. Now you have to think this through. Which one of these would be the easiest to eliminate? And I can do it by adding, subtracting, or multiplying. Well, see, I think it's going to be easiest to multiply by negative 1. If I multiply the first equation by negative 1, that's going to turn my positive 3y into a negative 3y. So I'm going to try to do that. So step 1, I'm going to eliminate one variable. I think I'm going to do that by multiplying by negative 1. So when I rewrite the first equation now, because I'm going to be distributing, I'm multiplying the whole equation by -1. So -1 times a positive, or times a -2x is a positive 2x. -1 times a positive 3y is a -3y equals -1 times a -9 is a positive 9. And then my second equation is staying the same. X plus 3y equals 3. Because I only multiplied the first equation by -1. Now I can solve by elimination. Because my -3y and my positive 3y are going to equal 0. So I'm going to add 2x plus x is 3x. -3y plus 3y is 0. 3 and 9 is 12. So then I'm left with 3x, because 0 is gone. 0 equals 12. In order to make x by itself, isolate the variable by dividing by positive 3, I can't speak today. And x equals 4. So again, I multiplied the first equation by -1 so that I would get a -3y, so that they would cancel out. I would eliminate that variable. Then I added up my equations and got x equals 4. So the last part, we already did step 1 here. We did step 2 here. The last part of this is for me to figure out what y is. Okay, I need to figure out what y is. So I need to plug x back into one of those equations. I'm going to take the second equation. Seems easiest. Alright, so I have x plus 3y equals 3. Alright, well we know that x is 4, so I'm going to plug that in. 4 plus 3y equals 3. Subtract by 4 on both sides. 3y equals 3 minus 4 is what? -1. Divide both sides by 3. Y equals -1/3. So if I write it as a ordered pair, I have 4, -1/3. Alright. Let's do example C. Takes practice. I have 2x plus 5y equals -22. And I have 10x plus 3y equals +22. So I'm going to have to look at those equations and say, I can multiply by something, or I can add or subtract in order to get two variables to be opposite so they can equal 0. Let's see. The second equation has a positive 10x, but the first equation has a positive 2x. So if I can multiply the first equation by -5, it'll be a negative 10x, and that'll equal 0. So you have to think through the problem. Okay, so I'm going to multiply my first equation by -5. That way I get what I want. Okay? Does everybody see how we do that? Yes or no? No? Kind of, sort of? Yes.
So, the goal for the, like, to get the numbers the same is kind of like when you're doing fractions and you have to find a common denominator?
Kind of. So you look at both equations and you figure out what's the easiest way to get one of those to be 0. Right? So if I multiplied this by negative 5, that means that I would have a negative 10x plus 10x. And that means that it would be, they would equal 0. That means I would eliminate 1. So you have to kind of figure out, like if I wanted to eliminate 5y and 3y, I would have to do a lot of work because I'd have to multiply both equations by, this one I'd have to multiply by negative 3. This equation I'd have to multiply by negative 5 in order to get 15, positive 15, negative 15 to cancel to 0. So let's look back at the first equation that we just did. Let's look back really quick. For this one right here, I saw that my easiest way to get rid of one of the variables was to multiply by negative 1 on the first one. That way I got minus 3y and a plus 3y so that they would equal 0. So I'm trying to get rid of one of the variables by eliminating it. And the way to eliminate it is to get them to equal 0. Kind of, sort of is okay. Take a second. So looking at this one that we're doing right now, okay, we want to multiply by negative 5 so that this would work out. So I'm going to multiply my first equation by negative 5. Okay, so if I were to do this and I'm distributing, what's negative 5 times a positive 2x? Negative 10x. Good. What's negative 5 times positive 5y? What's 5 times 5?
25, sorry.
What's negative 5 times positive 5? Negative 25y equals, then distribute the last one. Negative 5 times a negative 22. I'll do it for you. It's 110. Positive 110. And then now, look at, I'm going to write my second equation. Let it stay the same. 10x plus 3y equals 22. Do you see that? So I used my knowledge of, I know if I multiply by negative 5, I'm going to get a negative 10x. Negative 10x, positive 10x, they're going to cancel each other out. Okay? So now I'm going to solve for the eliminated variable. What's a negative 10x and a positive 10x is going to be 0. Plus negative 25. So it's like I'm adding straight up and down. Negative 25y plus 3 going to be negative 22y equals 110 plus 22 is 132. So it ends up being 0 minus 22y equals 132. So I'm adding the equations together. So when 0 is gone, I have negative 22y equals 132. Going to divide both sides by negative 22 to isolate the variable. They cancel, and y equals negative 6. So you can eliminate either variable. You just have to say, what's the easiest way? What's the easiest way to get positive and a negative to equal 0? Wake up. No. Okay, so now that I solved for y, I need to plug it back into one of the equations to solve for x. Okay? So let's plug it into the first equation. 2x plus 5y equals negative 22. we know that y is negative 6. So I have 2x plus 5 times negative 6 equals negative 22. 2x, what's positive 5 times negative 30? I give you the answer. Times negative 6 is negative 30 equals negative 22. So we're just solving algebraically like normal. Add 30 on both sides. 2x equals negative 22 plus 30 is 8. Divide by 2 on both sides. X equals 4. So the plugging it back in part is the easy part. That's the ending. So plug it back into one equation to get the answer. The hard part is thinking about which variable you want to eliminate. So if you write it as an ordered pair, I have 4 comma negative 6. X comma 1. Okay, and do another one. Example D. We have this and then a word problem. Alright, bear with me, stay there. 7x plus 3y equals 25. The second one is negative 2x minus y equals negative 8. Now let's look closely at both of those. What's the easiest way I can eliminate one variable? Let's see. I have 7x and negative 2x. That's going to be kind of hard to get them to be the same number. It's like Zola said, like finding a common denominator. Well, I have 3y and then a negative y. Is it going to be hard to get that to be the same number? No, because I can multiply by 3. You guys are so smart. Okay, so I'm going to multiply by 3 for this first equation. So my first equation stays the same. 7x plus 3y equals 25. We didn't change that equation. So let's look at the second equation that we're going to change. 3 times negative 2x is a negative 6x. 3 times negative y is a negative 3y. Right? And distributing as I go. 3 times negative 8 is negative 24. Boom. Now I can solve. 7x minus 6x is what? X. Then, oh look, this is going to be eliminated. Positive 3y and negative 3y is going to be 0. And 25 minus 24 is going to be 1. Well, this one's an easy one. X equals 1. So now I just need to plug it into one of the equations to get what y equals. So let's plug it into that first equation. 7x plus 3y equals 25. Let's go. So I'm going to plug it in. 7 times x, which is 1, plus 3y equals 25. 7 times 1 is 7, plus 3y equals 25. I need to get y by itself, so I'm subtracting 7 from both sides. 3y equals 25 minus 7, which is 18. Divide by 3 on both sides to isolate the variable. And y equals 6. So what is my Ordered pair, 1, 6. If you write down everything I write down, you'll be able to reference it for homework. Last problem we're going to do is a word problem, and then we'll check for understanding. Example 2, word problem types. Write with me. Suppose your community center sells a total of 292 basketball tickets. Suppose your community center sells a total of 292 basketball tickets. An adult ticket costs $3. An adult ticket costs $3. A student ticket cheap, costs $1. A student ticket costs $1. The sponsors collected a total of $470 from the game. So they had $470 in ticket sales. That's what they collected. Last part. Write and solve a system to find the number, stay with me, I know, of each type of ticket sold. That's it. So your community center sells a total of 292 tickets, but they don't know, how many of each ticket, right? Because an adult costs $3, a student costs $1, but they collected a total of $470 altogether. All right, so the first thing we want to do is we want to go through our word problem and just highlight the words or phrases that we think are going to be important to help us solve. All right, I think 292 tickets is important. 292 basketball tickets. I think that's important to know. I also think it's important to know that an adult is $3. Adult, $3. See, I'm using different colors. An adult is $3. A student is $1. And again, they had a total of $470 that they collected. They collected $470. So I know that those are the important parts of the problem. There's 292 tickets. Adults cost 3. Students cost 1. But all together we collected $470. So my first thing I'm going to do is write a variable for each of these things. So we're going to call adult tickets A. A is going to equal adult tickets. That's easy enough. Might as well use the letter it starts with, right? So A is going to be our adult tickets. S will represent the student tickets, right? So, if they had the adult and the student tickets, but we need to know how many tickets were all together. So, an adult plus the student tickets was a total of 292. You know that they took a total of 292 tickets, but that's adults plus the students. It's a mixture. We don't know how much of each. So that's our first equation. Adult plus a student is a total of 292. Our second equation has to be how much the adult was and how much the student was and the total amount that we have. So there were adult tickets, but they were $3 each. So 3 times the adult tickets, right? If I had 10 tickets from adults and multiply that by 3, that means I made $30, right?
Yes.
And then, thank you, my student tickets cost me $1, so it's $1 for a student ticket. So if I have $3 times how many adult tickets I have, and $1 times how many student tickets I have, I'll get the total amount, which is 470. So again, I took my adult tickets plus my student tickets to get the total amount of tickets sold. So that's like having 2 equations, right? 2 systems of equations. Now I need to solve it because they told me to write the equation, but the second part of the problem told me to solve it. So how am I going to do that? I need to do it by using elimination. So, if I look at these 2 equations, is it easier for me to get the 3a eliminated or the 1s eliminated? The 1s. So what will I have to do? Multiply the first equation by what? Negative 1. Beautiful. You guys are so smart. All right. So I'm going to multiply this first equation by negative 1. So I'm going to get negative 1 times a, which is negative a, and negative 1 times s, which is a negative 1s, equals negative 1 times 292, negative 292. And then my second equation stays the same. You writing this with me?
Yeah.
Okay. So then negative a, or 1a, plus 3 is what? Negative 1 plus 3 is 2. So 2a, these are eliminated because I have a negative 1s and a positive 1s. So plus 0 equals negative 292 plus 470 is 178. So I have 2a equals 178. Need to get a by itself. Divide by 2 on both sides. A equals 89. So there are 89 adult tickets, and there's a total of 292 tickets. So we can simply find the other equation. If A is 89, I'm going to plug it back into the equation. 89 plus S equals 292. We found out what A is already. Subtract 89 from both sides. Find out what S equals. And the student tickets were 203. So how many of each did I sell? How many tickets for each one? There were 89 adult tickets and 203 student tickets. So that's what you would write as your answer. 89 adult and 203 student. Thanks, Alex.